Alright, thank you for coming to our peristaltic pump demonstration. A few things before we get started. We are using the stepper motor from our Arduino kit. It is not the motor that we ordered for this project. It is not, the motor we ordered has not come in yet. The motor that we're using is a brushed DC motor with a planetary gearbox and a low RPM that is supposed to be a much higher torque, excuse me. This is our peristaltic pump rotor here. It is also a little oversized, and then it's supposed to come off and have a little bit of distance between this plate and here, and that is so that this part can clip onto the outside around the peristaltic pump, and then the rotor would fit into here. It would be attached to the motor shaft. This part has some compliant tabs that fit into this top part, so you can separate them, and then it clips back in. Not 100% dimensionally perfect on that either yet, but quite close. Again, there would be a longer shaft here, so this would be fixed, and then the enclosure for the electronics would sit above this piece and be kind of form factor up in here. For our demos, we have that we can turn our motor with Arduino control. So normally this would be a brush DC motor, and we would just hit it with, we would use an NPN transistor to control it on and off. We could use PWM if we needed to get a ramp up and down feature, but we are not going to incorporate that if we don't need to. But for this demo, we're just using the stepper motor. It's a simple function using the stepper motor on the Arduino.
Switching over to the Arduino itself, we need to go ahead and have variable control over how long that this motor actually operates for, and this will go ahead and produce different amount of water actually pumped so that the user can specify when they want like 4 ounces, 8 ounces, 16 ounces, etc. So in this case here, we have it directly hard-coded into the Arduino. This is going to run for about 15,000 milliseconds, and so we can do that, quickly show that on the demo here, that you can in fact change it. This is going to go ahead and just click it here, get my finger out of the way, and as you can see, the pump will actually start moving. Like I said, this is hard-coded, but when the proper UI is completely finished, the user will be able to specify exactly what quantity they want, and the pump will run for that amount. Switching over to the actual metrics collection of the Arduino collection here. So we have, as a simple placeholder for the motor that we don't have, we have a normal low torque DC brush motor. And so this one has 2 functions. It has to be able to collect the voltage data that the motor is consuming, as well as the time it is running for. And so by doing this, you can actually go over here, and then inside of the internal program that we run in the user UI, it'll go ahead and display these out. Let me go ahead and click this button over here, and this is just going to turn on my motor. And so what we're doing here is collecting the data on how long the DC motor is running for, and then as well as the voltage that it's running for. And these are just some calculations on the current, and then as well as like the kilowatts, or sorry, watts that it's going to run for. So if I go ahead and apply just a little bit of torque to this one, I'm just going to use my finger for this one, it'll start having a lower draw until it eventually reaches a stall. And then as you can see on this side here, we have a stall detection light as well that will turn on and off. And so this one will just go ahead and alert the user, in this case, of a pump clog or filter failure in some of those regards.